Hello, Algebra 2 students. It is Wednesday, January 13th, and you guys have this amazing Ed puzzle to watch. I do have office hours today from 12 to 2, so please stop on by, as well as Thursday and Friday this week. So the other day we did some SAT questions, and we didn't really have a time to go over the explanation, so I wanted to make sure that we did this quickly, and if you had questions, just come and talk to me. I'd love to talk more in depth if you need more of an explanation. So you did these the other day. It was either Thursday and Friday. And um, let's give you the answers and kind of go over them and make sure that your explanation works. Okay. So for number one, it is the graph of this quadratic function, and it shows the x-intercepts and the y-intercepts. Which graph represents this? Well, I'm going to start off by telling you that the answer is B. Okay. Now, there are some things that you need to know. So if you know that your intercepts are at at 6 and -2, that means that you can figure out what your axis of symmetry is because it is directly in between those two intercepts. So you have to find out what's in between -2 and 6. So you want to find the midpoint of those. That would be x equals 2. That means this vertex right here is 2 comma something, right? So that eliminates, because this is my vertex form, that eliminates A and it eliminates D. And in SATs, if you can eliminate 2 questions, then that's fabulous. If you're stuck and you're not sure where to go, you can just look at one of those and then you have a 50-50 chance. And you should never leave SAT questions blank. Always pick some solution. Okay, but now I need to move quickly because SAT questions, you only get a minute and a half or so to answer them. I have to decide which one of these is true. I only have one other point. I have 0, 6. And you're going to check one of these and figure out if it's true. If it's true, then that's the answer. If it's not true, then the other one is the answer. So I'm going to plug it in to B. So I would get 6 equals -1/2, 0 minus 2 squared plus 8. Is 6 equal to -1/2? -2 squared is 4 plus 8. Is 6 equals -2 plus 8? It is. That's my answer. Right. What I mean by if you plugged it into C, you'd get 6 equals -1/2. 0 minus 2 plus 9. You would get 6 equals -2 plus 9, or 6 equals 7, which is not true. So your answer has to be B. For number 2, you have these two solutions here. This is a lot of just trying to figure out what can actually work. So this is on the calculator type question, and you just need to try and figure it out. So you have two numbers. When you add them together and square them, you get 324. So if you can take the square root of both of those, you can see that those two numbers, when you add them together, you get the square root of 324, which is 18. Same thing here. You have two numbers. When you subtract them, you get they equal the square root of 16, which is 4. So you have to just go through your list of numbers. What are some numbers when you add them together? They're 18, but when you subtract them, they're 4. And you can just, you could make a whole list, but you could just start guessing, like 15 and 3. They add to 18, but it doesn't subtract to 4. So pick another number. Maybe you pick 10 and 8. And I pick that number. That adds to 18, but 10 minus 8 is not 4. Okay, so you just keep on going. Oh, wait, 11 and 7. When you add them together, you get 18. So 11 plus 7 equals 18. 11 minus 7 equals 4. Fabulous. Those are my two numbers, but it doesn't ask for those numbers. They ask for the value of what is x times y, which is 77. Okay. And then this last one, and I'm going to post this document on Google Classroom, so if you need to go back and look at it, it will be there. For this next one, this is a little bit trickier, but all it is the box method, right? So you're multiplying these two things together, and it has to equal this. So I'm going to make this box method real quick, and then I'm going to compare it to what my answer is. So this is ax plus b, 2x minus 5. All right, when I multiply these together, I get 2ax squared, 2bx, negative 5ax, and negative 30. So I'm going to write out all those things so you can see them. Okay, but they told us that it wanted to equal this. 12x squared plus kx minus 10. Oh, this is, let me go back. This is negative 5b. Looks better. All right. So that means that you're supposed to look and you need to figure out what A and B is. So that's really what it's asking. So if 12 is where this 2a square is, you need to know that A is 6. So it's basically saying when you multiply these two together, ax and 2x, and it gives you 12x squared, you need to know A is 6 to make that happen. The other part is that you have negative, oh, I made a mistake. Let me go back and fix that. I'm sorry. That's why that didn't look right. This is not a 6. This is a B. So sorry. B. So this is negative 5B. Okay, better. Okay. See what I get for going too fast. So now I want to compare these things. If I know that this last term is negative 10, and I'm looking at B and negative 5, and I'm multiplying those two together to get negative 10, I have to figure out that B is 2. Okay. So if I know that those are what my two values are, to figure out K, I'm going to plug in those values. So I'm going to go right here. So I get 2 times 2x, because B is 2, minus 5 times 6x, because A is 6. So I get 4x minus 30x is negative 26x. And that means that the value for K is negative 26. So your answer is A. Okay. So these ones, I picked some problems. These were trickier ones. But if you kind of work through and use what you know, the more that you practice these SAT problems, the better they are. So Khan Academy is an amazing resource. And there are lots of practice problems online. Okay, so those are the SAT questions. Now, in your notes, you want to make sure that when you submit these today, you submit a photo of your notes, that you have these examples for how to simplify a radical. Okay, so you want to put the date on your page. Today's the 13th. Here we go. And you're going to submit a photo, and then you're going to answer a couple questions at the end. All right, so there's a couple of skills that go along with quadratics, and they are simplifying radicals. So I just found a quick example to write it because there's a couple of different ways that teachers teach them. And I want to pick the way that makes sense to you. I tend to always do this prime factor thing, but if you've learned it another way or you've seen it another way and it makes sense, that's okay with me. All right, so in your notes, you want to write down that we have the square root, this is problem number 1, square root of 24. And the directions are always going to be for you to simplify it. What that means is that you're going to take 24 and you're going to break it down into its prime factors. So you go through your list. What multiplies to make 24? And maybe you think 4 and 6 or 3 and 8, it doesn't matter. And then you break them down a little bit more. Right? When you break them down into the prime factors, you've broken them down into as far as they can go. So that means my answer, or my next step, is 2 times 2 times 2 times 3, because that will give me 24. Now you want to just take what you already know about radicals and kind of keep that in your mind, right? So you guys know that the square root of 25, I know that you know that that's 5. And the reason why is because if you have 5 times 5, there is a pair of these. There's 2 of them. So I can take those and they go outside the radical and I get 5. So anytime you have a pair of numbers, that pair will come outside the radical. Okay. So when I have the square root of 24 and I break it down, I'm going to take this pair of 2's. That one is going to come outside my radical. But I'm not taking that. I'm not taking the number 4. I'm taking 2 because that's what you did here, right? The square root of 25 is 5 times 5. A 5 comes out of your radical. So the 2 comes out of your radical, and whatever's left underneath stays underneath. So 2 times 3 is 6. Okay, so that's how you simplify that square root of 24. Okay, so try the square root of 80. You can break it down as far as you can. 8 times 10. 2 times 5. Now, no matter how you break this down, you will always have that same factors, even if you did 8 times 10 or 2 times 40 and you broke it down that way. So these are all the numbers. These are all my prime factors that go underneath the radical because this is what multiplies to make 80. Now you're going to take these things out in pairs. Here's a pair of 2's. It comes on the outside. Here's a pair of 2's. It comes on the outside. You have a 5 left underneath your radical. That stays underneath your radical. So your final solution here is 4 root 5. Okay. All right, let's try one more. Right, of course, I'm going to throw a negative 1 in because that's our new idea as of just the other day, is that if you have the square root of negative 1, it equals I. Okay, so I'm going to break this down. The square root of negative 28 is negative 1 times 28. And then I'm going to break down 28 as 4 times 7. So this breaks down as negative 1 times 2 times 2 times 7. Right. Well, the square root of negative 1 is I. That comes on your outside. I have a pair of 2's. That comes on the outside. And then that square root of 7 stays inside. So when you simplify this radical, you'd get 2I root 7. Okay. Right, let's try a couple more problems. Okay, and this answer key will be on Google Classroom. So if you need to go back and look at the steps, you certainly can. Or you can pause the video, whatever you need to do. All right, this is the other part that we've been talking about, or that we started talking about the other day, is complex numbers. There's a real part and there's an imaginary part. On the SAT, they're going to tell you that I equals the square root of negative 1. You need to know that I squared equals negative 1. Okay, so we're going to try 2 problems. The first one we're going to try is 7I squared. So when you rewrite this, you get 7i times 7i, and you get 49i squared, which is lovely. But I squared is -1. So this is 49 times -1. And when you simplify it, you would get -49. All right, so here's our last one. We're going to, problem number 5. It's 3 plus 4i times 2 minus 7i. So I'm going to multiply this out. Hopefully you're thinking to yourself, oh yeah, that's this box method. Three plus 4i, 2 minus 7i. So fill in the boxes just like you've done every time. So 3 times 2 is 6. 2 times 4i is 8i. -21i. And then my last one is -28i squared. So I'm going to write out all the terms. 6 plus 8i minus 21i minus 28i squared. All right, well, I'm going to combine these ones together first. So I get 6 plus 8 minus 21 is -13i minus 28i squared. But I squared is, so I get 6 minus 13i plus 28. Right, and the last part I'm going to do is I'm going to add together these real part. 28 and 6 is 34 minus 13i. And you leave it just like that. And that's the way you want to write it too, because it has the real part first. And then it has the imaginary part first and the second, sorry. So there's your complex number. Okay, so those are kind of the 5 problems that we're going to try. We're going to keep working on those as well as quadratics because we're just about ready to kind of move on to a new topic. In the Ed puzzle, I am going to put 4 SAT prep questions. So they're in the document, so you can just do the document first. And then I'm going to have you guys just put your answers in the Ed puzzle and just try your best. All right, obviously I'm not grading you if you get SAT prep questions correct, but I wanted to give you a time to practice and to see after you put an answer if it was right or not. We can, of course, talk about these in an afternoon class if you guys let me know if there's a specific one that you'd like to go over. Okay, so I'm going to leave a little bit of space right here so I can input the questions, but I hope you guys have a good day.